Okay, so this is this way. All right, so this is section 2.3. Yeah, 2.3. And this is on triangle theorems. Okay? That's what we're on today. Now, the biggest thing that when we look at triangle theorems and we have to ask ourselves is this, okay? 1, is it a triangle? Can it form a triangle? Cannot form a triangle, okay? So, the big takeaway here essentially is that unless the sum of the two smaller legs of a triangle is greater than the larger leg, it doesn't work. Okay? Does that make sense? Otherwise, you got a problem. You get this scenario. Right? It collapses on itself. And not evenly, might I add, either. So, let's take a look at a few of these. And here's the formula for this. A plus B is greater than C. Remember these letters? They should look awfully familiar to you. You should remember them from Pythagorean and theorem. A squared plus B squared equals C squared. Right? Everybody remember that? Or at least that hopefully rings a bell? I'm getting one or maybe two questionable looks in the back of the room. Okay. Now, big thing is, it is not equal. Okay, don't make that mistake in mixing this up with the Pythagorean theorem formula. They're not the same thing. So, let's just look at a quick few examples. All right? 1 plus 1 is greater than 6. Nope. No. Doesn't work. What about the next one? Okay? Also, how you tell the difference is that this is C. This is A. And this is B, respectively. A and B can be interchanged, to be honest. But what's more important is we identify who C is, okay? All right, so for that one, we have 7 plus 9 is greater than 21, which becomes 16 plus is greater than 21. Nope, that fails. So, no, it is not. Okay, the next one. Does the next one fail or succeed? 6, 10, and 8. How many say it succeeds? Show the hands. See, 1. I mean, everybody else thinks it fails? Can't be only one person thinks it succeeds. Come on. Two. I see 2. There we go. I'll take 2 for now. All right. Yes, it does succeed. All right. 6 plus 8 is greater than 10. 14 plus 14 is greater than 10 because 6 plus 8 is 14. So, yes. Stand by a second. All right. So, and the last one, we've got 3 plus 8 is greater than 11. Okay, and 11 is greater than 11. This is not an equal to scenario. That doesn't work, so no. Okay? This is great to have in a pinch if you want to see something's a triangle before you even solve it. Okay? Any questions on that? Pretty straightforward stuff, I think, though. Hopefully nothing too scary yet. All right. So let's talk about down here what type of triangle. All right, we got a few in the past here. So we already know what Pythagorean theorem is, right? If a triangle is a right triangle, then the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse, right? Which we all know that formula as, say it with me, a squared plus b squared equals c squared. I heard a few people. All right. A squared plus b squared equals c squared. Or if you want to be fancy, leg squared plus leg squared equals hypotenuse squared, HYP. Either one's for it, fine. All right. If triangle ABC is a right triangle, then a squared plus b squared equals c squared. Notice that the angle C is directly across from side C, which is also the hypotenuse. Okay? This will hold true for every single triangle we look at. I know that's relatively small, I'm sorry, but that is side C right here. This is A and this is B. It corresponds to the correct angles, which make up the triangle, right? So, where do we use these situations? Well, we mainly use them when we're talking about ladders and putting them on the side of a house, right? You want to figure out how high you need a ladder to get to the side of the house. You can use Pythagorean theorem to figure it out. Okay? So let's say, for example, that Jamala, is that how you say that name? I don't know. Jamala leans a 12-foot ladder along the side of the house. The base ladder is 4 feet from the house. To the nearest tenth of a foot, how high is the house does the ladder reach? So, here's what we know. There's a really tiny space to work with, honestly. I'm sorry. So we've got a ladder. Got the side of a house. Right? I'm going to use L for ladder. I'm going to use the house for H. And I'm going to use the base for ground as G. Okay? We know that my ladder is 12, right? We know my base is 4. This is a right angle. And we know the house value is what we're trying to find, so we're going to note it as X. Okay? So let's break out that formula. What's the setup going to be? 4 squared plus x squared equals 12 squared. What's 4 squared? Ooh, boy. 16. We're going back to the old stuff. Plus x squared. What's 12 squared? 144. Very good. Yes. 144. Right? Subtract 16 from this side. I get x squared is equal to 128. I'm going to square root both sides. I know it's tiny. Sorry. That's why I'm just saying it all out loud. Okay? And I get that x is roughly, what's the square root of 128? That one you're definitely going to need a calculator for. We're going to round, obviously, to the nearest foot, which means we're going to round to the first decimal place. Is it really tiny? I know, I'm sorry. I can't zoom in because I'm recording it for everyone at home who's stuck at home right now. I will add it to Canvas here once we get done with the notes, so if you need to go back and get any clarifications, it'll be on Canvas. Not unless I just move it closer. Kind of works. Kind of out of focus. All right. So x would equal 11.3 feet. Okay. Now, the other one is called the Pythagorean triple. It's a generalization of a triangle theorem which can classify not only right triangles, but obtuse and acute triangles as well. Meaning that, hey, guess what? You can use this actually on triangles that are not right angles. Yay! How often will that come up for you guys? Next to nothing. But we still need to cover it. So, how we know? Right is equal to c squared. Obtuse is greater than c squared. And acute is less than c squared. That's how you tell the difference. Nothing crazy. All right. Yes. All right, give that a second. Okay, so apparently there's a typo on this one that so that S should be a 12. So it's 12.5 in the front. Okay. So first of all, we got to check and see if this triangle works. Okay, so if we add all of these numbers together, right, 12.5 and 30, we get, what, 42.5? 42.5, and that is indeed greater than 32.5. Checks out. So it's good to go. Okay, because this is my C value right here. Which means I can figure out if it's a right triangle or not, right? So if I do 12.5 squared plus 30 squared, and I'm going to try and figure out what the sign is, this is how this works, 32.5 squared, is 32.5 squared greater than, less than, or equal to 12.5 squared plus 30 squared? You have to break out a calculator. Yeah, so 32.5 squared. So if we square this value, is he going to be the same as the sum of these guys or greater than or equal to the sum of those guys? Well, we're just squaring them. We're computing to see if which of these inequality symbols we're going to use, if any. So somebody square 32.5, and somebody take the sum of the other two and square them. Use my phone calculator because unfortunately my calculator's over there. So 12.5 squared plus 30 squared gives me 1,056.25. Okay. And 32.5 squared gives me 1,056.25. So they're equal to, which means this is which one? It is A. There's an equal to. That's an equal sign in there. I'm sorry, but what are they equal? Which one is it? First, second, or third? Huh? Not third. Oh, first. I think it's the third. Sorry. First. Yes, it's a right triangle. So it is a right triangle. Hooray! I know it's really small. I'm sorry. Okay. The next one. We have 5, 9, and 12. 12 is C. 4 plus 9 is what? 13 is greater than 12. So if I go ahead and do my check here, I've got 4 plus 9. They're all squared, equal to something. 12 squared. What's 4 squared? What's 4 squared, guys? 16. What's 9 squared? What's 16 plus 81? 97. Okay. And what is 12 squared? 144. So which one side's bigger? This side. So it's this way, which means it's which one? Obtuse, acute, or right? Obtuse. This is an obtuse triangle. I saw the hand. 1 second. Okay. C squared is bigger. All right. What's your question? Devin. Oh, just answer. All right. Again, this will be on Canvas, so if it's really small, I'm sorry. But there should be a digital copy you can zoom in on real close. All right. Any questions on that so far? Everybody good? Okay. Next up. All right, the $1 million question. What do all angles add up to in all triangles? Every single time. Regardless of shape, regardless of size. Not 160, close. What? You said 360? Okay, not even close. Corbin, what'd you say? 180. You're thinking of circles. Yeah, that's fine. So just take that number, cut it in half. All right, anybody see that video before? It's like, I'll cut it in half. No? Sign in happiness? Never mind. All right. 180 degrees. Okay? What is special about exterior angles? Triangle exterior angle theorem. The measure of each exterior angle is the triangle of a triangle is equal to the sum of its two remote interior angles. Okay? Basically means that angle 2 and angle 3 equal angle 1. Okay? The exterior angle are angles formed by a continuing side of a triangle on outside. Okay? The remote interior angles, on the other hand, okay, are two angles inside, not touching the exterior angle, aka non-adjacent. What does adjacent mean? What does adjacent mean? Anybody here play chess? Or heard of, did anybody know what chess is? What do I say when I say that the pawn is adjacent to the knight on my board? What? Next to. So when I say adjacent, that means next to. The angles are not next to one. That means this angle right here is not included in this mess. Throw them out when I'm talking about special exterior angles. All right. Next up, everybody's favorite pal. We've all heard him. We all love him. The isosceles triangle. Okay. Here we go. This right here is called a vertex angle. Okay? This right here is a leg. This right here is a leg. We got an angle. We got an angle. Base. Both of these right here are referred to as base angles. Okay? That is an E down there. I'm sorry. It just looks really fat. Okay? And all of this is in one triangle. Okay? If two sides are congruent, then the angles opposite to those sides are congruent in one triangle. Okay? Easy peasy. All right. Everybody have that down? Okay, next slide. Or next slide, next page. What is called when you connect one midpoint to another midpoint in a triangle? This is what we call the triangle mid-segment theorem. Okay? You've probably seen these a million times on tests, if not earlier. They are very popular, and they sometimes even throw a fourth side on this to turn into a discount crazy-looking trapezoid that's been trying to cut in half, and they messed up the line or something. It's just ugly. Well, we're going to master how to solve all that mess. First up, one thing you need to note, that this line and this line are parallel. Okay? And because of that, and because this is the mid-segment theorem, we can state the following. That line DE is equal to 1/2 of line AB. Or AB is equal to 2 DE. Does everybody see that? See how that works? Make sense? Okay. So, for the first one, okay, if that's the case, well then guess what? This line and this line are congruent, this line and this line and this line and this line are congruent because of how the mid-segment theorem works, which means if we come down here and take a look at this dude, we know that this dude and this guy are parallel, which means, guess what? This side is congruent to this side, which means I can do what with those two things? Hi, welcome back. In there are 2 pages you need to grab, not the test. So that's the honors test. I don't think you want that. Yeah, that. There should be 2 pages there. Nope. All right. So that means we can set these equal to each other, right? Because they're congruent, right? Similar means we can set them equal to. So we get 2x plus 4 equals x plus 9. Okay? If we solve for our x value, we should get, or at least try and get things by itself, we get x plus 4 equals 9, which gives me x equals 5. Okay? So that means that this right here is, what's 5 plus 9? What's 2 times 4? And what's Sorry, 2 times 5. I said 4. 2 times 5. 10. And 10 plus 4? Yep. If these do not equal to each other, which is why I messed up when I said 4, I was going to get 12. I was like, that's not right. Then something's wrong. Because they're congruent. They have to be the same, right? Okay? All right. Next one. Okay? We're looking at this angle and this angle. Okay? Look back to your angle theorems. What can we say about these two angles from yesterday? If these guys are parallel, which means these guys... Sorry, these guys are congruent. These guys are parallel. So what does that mean for that angle? What does that mean x has to be? Look back in your notes, guys, from yesterday and look at that beautiful little sheet I gave you that has all the theorems and we color-coded it. What does that angle have to be? Or what do you think it is? Anyone? It's 71. Why? Corresponding angles. If we look back from yesterday, okay, go over to corresponding angles. Oh, that's all. Corresponding angle theorem at the top. Corresponding angles are angles that are congruent. Angles like AE. AE. That looks awfully familiar. It's just backwards. That makes sense? This from here on out, guys, is going to build on itself very quickly. So that means that x equals 71 because of corresponding angles. Okay? And finally, okay? Now, this may look crazy. This may look scary. I promise you it's not that hard. Okay? First of all, identify our parallel lines. Awesome. Secondly, isolate our x's and figure out what the heck's going on. Okay? We know that this guy right here is 3x minus 6, right? We know that from that we can state the following. Because if we find half of this guy, right, we cut him in half, we can find what x is because this side and this side are across each other. This is, again, going back to like the puzzle situation. So x equals 1/2 of 3x minus 6. If we simplify this and solve for x, we get 2x equals 3x. Then multiply both sides by 2, right, to get rid of that fraction. Don't want to deal with it. Solve for x, and I get 6 equals x. My life just got a whole lot easier. So we know for a fact that 6 is right there. Okay? If you want to be really sneaky, you could, because this is technically a right triangle or unknown, well, we can use that theorem that we talked about earlier to see if it is, and then we can find the hypotenuse. But we can't really because we don't know what our height is yet. But we could if we knew. So can't use that option, but you have options here. Okay? So from there, we can then figure out what y is with the same plan. We have y equals 1/2 2x plus 1. And we know what x is because what x is x equal to 6. So we're going to plug them in. So we get y equals 1/2 of 13. Half of 13 is the decimal point of 6.5. Yay. So if we plug things in, we know this is 13. We know this is 12 because 3 times 6 is what? 3 times 6? 18. Minus 6 is 12. Okay? I think everything's labeled, and we know that this is 6.5 internally, and we're done. All right. Where's my? There it is. No, there we go.